Welcome back, and we're now going to talk about something called capacitance. Now, what is capacitance? Capacitance is the amount of charge stored per unit potential difference. If we were to summarize this mathematically, capacitance, we use capital letter C to symbolize it. We can say this is equals to amount of charge stored, so it's Q, per means divided by, so divided by the potential difference V. That is capacitance. Okay, now capacitance is measured in farads. You need to know the units of measurements for all the quantities that you will be calculating for. So when we talk capacitance, we measure that in farads. We talk potential difference, we measure it in volts. Okay, we talk current, electric current, we measure that in amperes. So in that way, remember, physical sciences, it's a subject in which we're talking science concepts, and we need to make sure that for everything we're talking about or we're calculating, we need to put a unit for it. It is not enough in science to just give an answer in a numerical form only, because mathematics is just the language in which we, the scientists, express ourselves in. So it is not enough to just say 5. 5 what? You need to put in a unit for what you're working on. Next, when we talk capacitance, there is no way we can talk capacitance without talking parallel plates. Now, there's something very special about parallel plates, and I will explain it as we move on. Parallel plates are used to build capacitors. These things, when you open a radio or TV set at the back there on that board there, you would see so many different colored cylindrical things there, okay? Those are capacitors, okay? They are different, big and small. They are making use of parallel plates. These, inside them, we've got parallel plates, and they make use of this parallel plates to function. There's something special about parallel plates. We know that between parallel plates, we've got what we call uniform electric field. Okay, now, when talking about capacitance and capacitors, when we get into the inside of the capacitor, we find that there's a substance that is used to separate the parallel plates inside that capacitor. We call that substance a dielectric. That substance could either be air, and air is mostly used as a dielectric in many parallel plates. It could be air, it could be any other substance that is not conductive to electric current. And we're going to see some of them as we move on. Different dielectrics have different permittivity. And what do we mean by permittivity? Permittivity is the measure of how well a dielectric, which is a non-conducting substance, dielectric, which is a non-conducting substance, how well, it's a measure of how well it permits electric current or electric field to pass through or between the plates, to move from one plate to the other. Okay. Next, here what I have are materials with their permittivity constants. In a vacuum where we've got no air, the permittivity is 1. When we make use of glass as a dielectric, permittivity is huge, between 5 and 10. When we use something called mica, the permittivity is 3 to 6. When we use polyvinyl materials, PVCs, we have permittivity to be 3.18. With water, we have got 80.4. Now, that is why it's very dangerous to play in rain when there is lightning. Look at how much able water is as a non-conducting substance to allow electric fields to pass through it. So it is a dangerous thing to be playing there. Air, almost close to vacuum. I didn't put down the decimals here, but it's almost 1 as well. So I kept it as 1. Now, calculating capacitance. Let's look at this example. A certain capacitor stores a charge of 24 microcoulombs when a potential difference of 12 volts is applied to it. Now, what is its capacitance? We know from the previous formula that we saw that capacitance equals charge over potential difference. So capacitance here would be equal to, what is that charge? We have to convert it into what? Into coulombs. It's in microcoulombs. So we'll multiply by 10 to minus 6. You divide that by the potential difference across it, and then you find the capacitance. 24 divided by 12 is 2. So the capacitance is 2 by 10 to the power minus 6 farad. Remember the unit of measurement for capacitance, it's farad. Now, I said with parallel plates, we've got something special about them. The special thing about parallel plates is that between them, we have what called uniform field. And how do we make sure that we're showing a uniform field? Between them, here and there, you can see you have got lines here that are representing the fields. They are equidistant from each other. In other words, the distance here and there is the same. Right, let's meet in the next section.